If you're looking for a fast, beginner-friendly time series database, you're in the right place. Today, I'll walk you through how to use QuestDB step by step. By the end of this video, you'll understand how to create a database, import data, use advanced features, and manage everything from the web console. Let's begin by creating a sample database. In QuestDB, all tables are created using simple SQL commands. Here's a basic example to create a table for IoT sensor data. This tells QuestDB that time is the timestamp column, which is key for time series data. Next up, importing CSVs. You can drag and drop a CSV directly into the web console. The console will automatically detect column names and types. Make sure your timestamps are in ISO format so QuestDB can parse them correctly. Once it's loaded, you'll see the new table appear on the right panel. Now let's look at materialized views. They're a powerful way to pre-compute results for fast queries. Let's have this one as an example. This speeds up analytics by reducing what has to be recalculated every time. Let's talk timestamps and time zones. QuestDB stores timestamps in nanoseconds and works with time zone-aware queries. To adjust the display, you can use the set time zone command or convert using @timezone. This is super useful when handling global data sources like satellites or international devices. For those of you using ZFS, you can enable compression for QuestDB storage. While QuestDB doesn't manage compression itself, ZFS works great behind the scenes. ZFS compression helps reduce disk usage without hurting performance. Just make sure your ZFS dataset is enabled with compression settings like LZ4. This setup works best for large historical datasets with lots of repeated values. Let's move on to the Enterprise Quick Start. If you're setting up QuestDB in a production environment, use Docker or Systemd for persistent service management. Enterprise users can benefit from authentication, role-based access, and encrypted endpoints. QuestDB provides configuration files to tweak memory, worker threads, and networking. If you want to handle high volumes, this is where you'll tune performance. Next is replication tuning. QuestDB supports multi-replica setups through log shipping and data snapshots. You can sync data from one instance to another using cron jobs or rsync for now. It's not yet built in like PostgreSQL, but it's very doable with automation. Replication helps you run backups, high availability, or read scaling for multiple dashboards. If you're a Java developer, you can embed QuestDB directly in your app. Use the QuestDB Java API or JDBC driver to execute queries from your application. Since it's written in Java, integration is smooth with Spring Boot, Micronaut, or even plain Java apps. This makes QuestDB ideal for real-time apps, embedded analytics, or local dashboards without a server. Now let's talk about modifying data. QuestDB supports update and delete, but they're not as fast as inserts since it's a column store database. That's why the best practice is to avoid frequent updates. Finally, let's explore the web console. This is where you'll write queries, import data, and explore your tables. It runs in your browser and connects to the local or cloud server. You can view charts, test queries, and explore metadata all from the same panel. It's lightweight, fast, and perfect for beginners. Let's also touch on QuestDB's performance monitoring and metrics. QuestDB exposes detailed internal metrics through a Prometheus-compatible endpoint. Lastly, a quick word on security and backups. QuestDB recommends firewalling your ports and using Nginx or reverse proxies for production deployments. While the free version doesn't come with built-in user access controls, you can restrict queries by IP or use SSH tunnels to protect your endpoints. For backup, simply stop the database and copy the DB folder or use a snapshot tool like LVM or ZFS to do it live. Automating backups weekly is a great safety net for your time series data. Another useful thing to know is how QuestDB handles partitioning. By default, time series tables are partitioned by day, but you can also set partitions by month or year. This improves performance for queries and also helps manage retention. For example, dropping data older than 6 months becomes a one-line command. To set it, use partition by month during table creation. It's an easy but powerful optimization for large datasets. And finally, don't forget about data ingestion methods. Besides CSV and the web console, QuestDB supports ILP, the influx line protocol, which means you can stream data over TCP. This is super handy for real-time feeds from sensors, trading systems, or log pipelines. Before we wrap up, let's do a quick recap of what you've learned. We covered how to create a sample time series database, import CSVs, and use advanced features like materialized views. You also saw how timestamps and time zones are handled, how to optimize storage with ZFS, and how to get started with enterprise features. We discussed replication, Java integration, modifying data safely, and using the built-in web console. And that's everything you need to get started with QuestDB as a beginner. From setup to streaming, from storage to performance tuning, whether you're working with IoT, sensors, financial data, or logs, QuestDB gives you serious speed without the complexity. Just start small, explore the features we covered, and you'll be confident in no time. This is How to Literally, where we keep things smart, simple, and scam-free. See you in the next one.